morning, dear students. Today we are going to start a new chapter, that is work and energy. So I am going to introduce work according to physics. What is work? So let us discuss what is work. Suppose you are working on computer, or if I am recording the video, am I doing the work? You are reading, you are reading a book for 1 hour or 2 hours, you are feeling tired. According to you, you are doing work. But in physics, there is something different, that how work is done. Physics, work is equal to force into displacement. Means force is what? Pull or push. Means when we push or pull an object, while pushing or pulling, the object moves, then it is said work is done. Means we see the examples. For example, a girl a girl is applying a force on this cart, and this cart is moving some distance in the direction of applied force. When object moves a distance in a particular direction, then we call it as displacement. What we call it as displacement. Means this girl is applying force and object is displacing. So work is done. Let us consider another example. See, this boy is pulling a wall, applying force on the wall. But in the result, wall is not moving. He is feeling so tired, he applied force for 2 hours or 3 hours, you can say, or for the full day. But wall is not moving. Then, according to physics, no work is done. Let us consider another examples. You can see a person is holding a barbell, right? But he is standing and holding it. So, in this condition, whether the work is done or not, think about it. Just let me know. No. No work is done. How? Let us see. He is applying a force just to balance the weight of this barbell, otherwise this barbell will fall down. He is applying force, but this barbell is not moving. It is not showing any displacement. It does not move. So no work is done. So means for work done, there should be two necessary conditions. Number one, force should be applied, and number two, object should show some displacement. Only then we can say work is done in physics. See, in this condition, the boy is holding the barbell and he is applying the force, and barbell moves from this position to this position. Force is applied and barbell is showing the displacement from this point to this point. Work is done? Yes, work is done because force is applying and object has shown the displacement, therefore work is done. Means it is fulfilling both the condition force and displacement. Applied force and object showed the displacement, so we can say work is done. Consider one more example. This barbell is lying over here and it falls. Nobody, no person is pushing it, but there is a force due to which it falls. Which force is acting on it? That is force of gravity and showing the displacement. So work is done? Yes, work is done. Means it is not necessary that a muscular force act on the object and it shows the displacement. Any force can act on it, and if object shows the displacement means work is done. Discuss work done in the numerical form. What is work? In physics, the formula of work is force into displacement. Work is denoted by W and F denotes the force, and for displacement we write the word S. Now consider this example that this girl is applying a force on this cart of 30 Newton. And this cart is moving a distance, means displacement of 2 meters. So how much work is done by this girl on this cart? So how we will calculate? The formula for this, W is equal to F into S. That is equal to force is 30 Newton. Displacement is 2 meter, so that will come out 60 Newton meter. So instead of learning unit of work, Newton meter, we will write joules, J, 60 joules. So joule is equal to Newton meter. That unit of work is joule, and joule J is equal to N into M. Definition of work. Work is defined as a force acting upon an object to cause a displacement, and it is expressed as the product of force and displacement in the direction of force. It can be represented as W is equal to F into S, where W is equal to work done on an object and F stands for force of on the object, S stands for displacement of the object. The unit of work is Newton meter or joule. And very important, define 1 joule. 1 joule is defined as the amount of work done by the force of 1 Newton when displacement is 1 meter. How we will define that? J is equal to N into M. J is 1, therefore N should be 1 and M should be 1. So 1 joule is defined as amount of work done by force of 1 Newton when displacement is 1 meter. Or you can define in your own words that when we apply force of 1 Newton on an object shows the displacement of 1 meter, then it is said 1 joule work is done. Necessary conditions for work to be done. There are two conditions that are needed that when work is done. Number one, force should act on the object. An object must be displaced. Means if object is not moving, then work done is zero. Or object is moving but no force is applied on it, then again work done is zero. Sign conventions for work done. Work done can be zero, work done can be positive, and work done can be negative. See, when both force and displacement are in the same direction, then positive work is done. W is equal to F into S. When force acts in the direction opposite to the direction of displacement, means force is applied in this direction and object is moving in the opposite direction, then work done is negative. If angle between force and displacement is 180, again the work done is negative. If force and displacement are inclined an angle less than 180, then work done is given as F W is equal to Fs cos theta. This is not now in your syllabus, but some books you can read it, so you should know that when you are pulling or pushing the object with an angle, then force is calculated like this. But in your syllabus you had only simple positive work done, negative work done. But you have to learn one thing: when force and displacement act an angle of 90 degree, then work done is zero. Means displacement is there, force is also applied, but angle between force and displacement is 90 degree, then work done is zero. Let us understand all these with examples. Example of positive work done and negative work done. As I have told you that W is equal to F into S. When force and displacement in same direction, work done positive. When force and displacement are in opposite direction, work done is negative. Consider this girl. She is applying force on this cart in this direction, and cart is also moving in the same direction. So work done is positive. Suppose, consider the another example. A car is moving. A Superman wants to stop. Car is moving in this direction, and Superman or you yourself stop the toy car. You apply the force on the car in right, and car is moving to the left. When force is applied in this direction and car was moving in this direction, then work done is negative. Means the direction of force and direction of displacement is opposite, then work done is negative. Means when we apply the force and displacement in the same direction, the speed of object increases. When these two are in the opposite direction, then speed decreases. And those people are standing and doing nothing. Neither they are applying force or not displacement is there, so their work done is zero. Consider another example. Suppose you throw a ball in upward direction. Ball is moving in upward, so tell me in which direction force of gravity is working on it. Obviously, the force of gravity is working on the ball in downward direction. So ball is moving upward, force is applied in downward, so work done will be negative. By which? By force of gravity. And suppose the ball, you are dropping the ball downward. Ball is coming downward. Force of gravity is working in the downward direction. So both direction of force and direction of displacement is same. So work done is positive. So the result is, in When they are working in the same direction, force and displacement, the object's speeds increases. When they two are working in the opposite direction, their speed of object decreases. So when it comes down, its speed increases. When it's go up, its speed is decreases. So that's all with the work done. Read it, and we will discuss the problems next day.